now this slide is there. So on this slide I will explain you the formulas. You write down it, copy it into the notebook, and then we will solve the problem on this unit. Okay, so this unit is very simple. Only just you need to remember the formula, and in that formula if you put the values you will get the answer. So simple is this. Okay, within 2 lectures this unit will get over. A very easy unit. Okay. So basically what we have seen the Prestress members and different types of Prestress members. Okay, and also we have calculated the resultant stresses in Prestress members, extreme stresses at end section, midspan section. All these things we have seen up till now. Now we will see the losses of prestress. So losses of prestress means what? When you are applying a prestressing force to the tendon, okay, then if you apply a force of 100 kilonewton, say if you apply a force of, suppose now 100 kilonewton, 100 kilonewton prestressing force if you apply, then this total 100 kilonewton is not going to transfer to that tendon. Okay, suppose now out of this 100 kilonewton, let's assume that 80 kilonewton is get transferred, okay, to that tendon. 80 kilonewton is get transferred, then this remaining 20 kilonewton force, this is nothing but this is the loss of prestress. This is nothing but this is the loss of prestress. Okay, so now we will see the different types of losses in the prestress member. We will see the different types of losses. Now basically these types of losses are divided into two categories. First is for pre-tensioning members and second is for post-tensioning members. So different types of losses are there for pre-tensioning members and for post-tensioning members. Now you know that what is pre-tensioning member and what is post-tensioning member. A pre-tensioning member is a member in which you have applied the stressing force to the tendon before concrete is poured into it. Okay, and for post tensioning member you cast the proper beam and the tendons, you apply the stressing force to the tendons after that concrete is hardened. Those types of members are post tensioning members. So now here in pre-tensioning there are four types of losses, and in post-tensioning, here if you see in pre-tensioning there are four types of losses. Okay, and in post-tensioning there are six types of losses. Okay, so average loss in pre-tensioning is near about 18%, and the average loss in post-tensioning is near about 15%. Okay, that is what it is not written over here, so I will write. So average loss here, it is near about 18% in pre-tensioning members, and average loss here in post-tensioning members is near about 15%. It is including all. Okay, so it is including all losses. So we will see the losses one by one. You can zoom into the screen from your mobile. Okay, so now first in pre-tensioning, relaxation of stress in steel. First loss is due to the relaxation of stress in steel. Okay, second loss is the shrinkage of concrete. So we will see later on in detail what does it mean. Shrinkage of concrete. Okay, concrete shrinks due to which there is a loss in pre-stress. Third is the creep of concrete. Creep of concrete means when you continuously apply a load on a member, then it undergoes creep. Okay, some permanent deformations, due to which there is a loss of some pre-stress. Then elastic shortening of concrete. Okay, next is the elastic shortening of concrete. These four types of losses are occurred in pre-tensioning members. Okay, in pre-tensioning members. Now for the post-tensioning members, if you see, same loss is there, relaxation of stress in steel. The second is also same, shrinkage of concrete. Third, creep of concrete. Okay, now the fourth loss, elastic shortening of concrete. So the elastic shortening of concrete, no stress due to elastic shortening of concrete if the wires are simultaneously tensioned. Okay, if the wires, all the wires are tensioned at a time, that is simultaneously, then this loss due to elastic shortening of concrete is zero in pre-tensioning members. And but if the wires are successively tensioned, means one by one, okay, if the wires or tendons are successively, that is one by one, those are pre-stressing force are applied on the wire, then this stress will be present in pre-tension, post-tensioning members. Okay, and if the all the wires are simultaneously tensioned, then the value of this elastic shortening of concrete, loss of stress due to elastic shortening of concrete, is zero. Okay, then the fifth loss is friction. Okay, loss due to friction. And then the sixth is anchorage slip. Okay, so these two losses are the additional losses in the post tensioning member as compared to pre tensioning member. And in pre tensioning member, if the wires are simultaneously stressed or successively stressed, one by one stressed, elastic shortening or loss due to elastic shortening of concrete will be there. Okay, but in the case of post tensioning members, if the wires are shortened simultaneously or wires are tensioned simultaneously, then the loss due to elastic shortening is zero. And if it is tensioned one by one, then the loss due to elastic shortening is there. Okay, so there are some formulas to calculate these losses. Okay, so you are going to calculate these losses based on the formulas. So we will see it now. Okay, so I will clear all the drawings first. So now the first, loss due to shrinkage of concrete. Okay. First thing is loss due to shrinkage of concrete. You can zoom your screen, okay, so that it is readable to you, and write down the formula whatever given over here. While solving the problem, we will use this formula. So loss due to shrinkage of concrete. So first we will see this shrinkage of concrete, loss due to shrinkage of concrete. The shrinkage of concrete in a prestressed member results in shortening of steel wires. Hence, it contributes to the loss of stress. Okay, it results in the shortening of steel wires. Okay, I hope now you know the term shrinkage and creep. In concrete technology second year we have seen that. What is the shrinkage of concrete and creep of concrete. So now due to the shrinkage of concrete, prestressed members results in the shortening of steel wires. Shortening of steel wires are there, and hence it contributes to the loss of stress. The use of high strength of concrete with low water cement ratio results in the reduction in shrinkage and loss of prestress. Okay, so how it can be reduced? By using the high strength concrete and low water cement ratio. Okay, this can reduce the shrinkage of concrete, and subsequently it can reduce the loss of prestress also. So the formula which is most important, this is the formula. This formula we are going to use to calculate the loss due to shrinkage of concrete. And what does the formula says? The loss due to shrinkage of concrete is ECS into ES. Okay, where ES is the modulus of elasticity of the steel. Okay, ES is the modulus of elasticity of the steel, and ECS is the shrinkage strain. Okay, ECS is nothing but, this is, I will write over here, this is called as shrinkage strain. This is your shrinkage strain. Okay. So how to calculate the shrinkage strain, that we will see. It is also having some formula to calculate this value of ES. Just now you remember this. If you want to calculate the loss of stress due to the shrinkage of concrete, then your formula is ECS into ES, where ES, you already know this term, modulus of elasticity of steel. It is nothing but your ES, and ECS is nothing but shrinkage strain. Okay, So now here the formula is given for the calculation of this shrinkage strain. Okay. So for pre-tensioning members, ES is equal to, what is the formula? 300 into 10 raised to minus 6. Okay, so I will write here the formula so you can understand. Okay, for pre-tensioning members, okay, for pre-tensioning, okay, what is the formula for ECS? ECS is equal to, what is ECS? It is shrinkage strain. This is shrinkage strain. Okay. And how do we calculate the shrinkage strain? This is the shrinkage strain, and how do we calculate it? So ECS is equal to, what is it? It is 300 into 10 to the power minus 6. Okay, in the case of this pretensioning. In the case of this pretensioning. Okay, and for post tensioning, this value is ECS is equal to, it is 200 into 10 to the power minus 6 divided by log, okay, log t plus 2 to the base 10. Okay, it is log not to the base e, it is the log to the base 10, where this t is nothing but t is equal to what? It is age of concrete. So how old the concrete is? Okay, this is the age of concrete. So by using these two formulas, depending upon the problem given, if you are calculating the shrinkage strain for pre-tensioning, then the formula is here 300 into 10 raised to minus 6, and if you are calculating the shrinkage strain for post tensioning, then this formula you are going to use. Okay, where in this formula all other terms are constant, only t is equal to age of concrete. Okay. And why we are calculating this formula? Ultimately we want to find out, ultimately we want to find out the loss of prestress. Okay, loss of prestress due to what? Due to shrinkage of concrete. Okay, due to shrinkage of concrete, and its formula is ECS, that is shrinkage strain into Young's modulus of steel, and its formula is shrinkage strain into Young's modulus of steel. And to calculate this, okay, to calculate this value of shrinkage strain, these two formulas are there. These two formulas are there. Okay, so this is about the shrinkage of concrete. Okay, write down the formula, also take the screenshots. So now after this, next is the creep of concrete. Okay, so the creep of concrete, it is calculated by two methods. First is ultimate creep strain method, and second is the creep coefficient method. Okay, this is calculated by two ways. The first way, it is by using ultimate creep strain method. Okay, and second is the creep coefficient method. In the numerical, if the creep coefficient method, in the numerical, if the value of creep coefficient is given, then you have to use the creep coefficient method. Okay. And if it is not given, then you have to use the ultimate creep strain method. Depending upon the formula, there are two different formulas. Depending upon the given data in the numerical, you need to choose which method you are using, you will use to calculate the creep of concrete. So here it is, creep of concrete means the deformation of the concrete which depends upon the interval of time to which the member is loaded. Okay, to which the member is loaded. So for a certain interval of the time, if the member is loaded, then there is certain deformation in that member, and this phenomenon is known as the creep of the concrete. The creeps are getting developed in the concrete. So the first method to calculate this creep of concrete is ultimate creep strain method. So first is the ultimate creep strain method, and by this ultimate creep strain method, what is the formula? The loss of stress due to creep of concrete. Okay. So the loss of stress due to creep of concrete, it is EC into FC into ES. It is EC. Here it is ECS. Don't get confused. ECS means shrinkage strain of concrete. C stands for concrete, S stands for shrinkage strain. And now here loss of stress due to creep of concrete. It is EC into FC into ES. Okay. So what is the meaning of EC? EC is the ultimate creep strain. This value normally it is given in the problem. Ultimate creep strain, that is the EC. In some books, the notation for this, it can be also used as ECC. Okay, creep strain in concrete, and ECS means shrinkage strain in concrete. These types of notations also used. So EC into FC, FC is the compressive stress in concrete at the level of steel. Okay, so at which level the steel is placed, at that level we are going to calculate the stress in concrete. So it can be calculated as, for FC the formula is this FC, it can be calculated as P by A, that is the initial stress, plus P E square by I. Okay, where P0 is the initial pre-stressing force. This is the P0 stands for initial pre-stressing force, or in some book PI is also given, initial pre-stressing force. So this FC can be calculated as P by A plus PE square by I. This is the formula. So to calculate the FC. Then ES, this is already known to you, modulus of elasticity of steel. Okay. So this is the ultimate creep strain method. Write down this formula. This formula is most important. And what is FC? FC is the compressive stress in concrete at the level of steel. Okay. So stress in concrete at the level of steel, it is nothing but FC. So, okay. So now next is this is your ultimate creep strain method. Now next is the creep coefficient method. Okay. So to see that method, creep coefficient method. So here you can see I have again written what is meaning of creep. If you don't understand the word creep, creep is nothing but it is the deformation of structure under the sustained load. Okay. For elastic or long-term deformation of structure under continuous load. So loss of stress due to creep of concrete, the formula is given over here. You can see this formula. This is the formula. The loss of stress due to creep of concrete is phi into m into fc, where phi is the creep coefficient and it is calculated as creep strain divided by elastic strain. Okay, creep strain divided by elastic strain. So if I write over here, this is denoted, the creep coefficient, it is denoted by letter phi. Here is also phi is given, and phi is equal to, it is creep strain divided by elastic strain. So we will get the creep coefficient value. And now the loss of stress due to creep of concrete, it is m phi into m into hc, where phi is the creep coefficient, m is the modular ratio. Okay. M is the modular ratio, that the value of m, it can be calculated as Young's modulus of steel divided by Young's modulus of concrete. Es upon EC, that gives you the value m, and Fc is nothing but, just we have seen, it is the stress in the concrete at the level of steel. How do we calculate the Fc? The formula to calculate the Fc is P by A plus P E square by I, where P is the initial prestressing force. Where P is the initial prestressing force. Now you can see the table which is given over here. So these are the creep coefficient values. Okay. So depending upon the age of loading, okay, how much days the loading is given to the concrete. So age of loading is given over here. So if you apply the load to the concrete continuously for the 7 days, then the creep coefficient value phi is 2.2. Okay. Sometimes these phi values are not given in the examination. You have to remember these values. For MCQ also these values can be asked. Okay. So the value of creep coefficient for age of loading of 28 days, it is dash dash dash. Okay, and the options will be given to you, and you have to choose one correct option. So for MCQ also this question can be asked. So here for 7 days the value of creep coefficient is 2.2. For 28 days it is 1.6. For 1 year it is 1.1. So these are the values of creep coefficient. Okay. So now loss due to relaxation in steel. That is, this is called as creep of steel. Just now we have seen the creep of concrete. Okay, then relaxation in steel means what? Loss due to relaxation of steel means another word for that is creep in steel. Okay, so this is very simple loss. Steel also possesses the property of creep. The percentage of creep varies from 1% to 5%. Normally it is taken as 3%. So the loss due to the relaxation of steel, it is taken as 3%. Okay, and it varies from 1% to 5%. While solving the problem, we will see how to calculate this loss. Loss due to relaxation in steel. Okay, loss due to relaxation in steel. Now after this is the fourth, elastic shortening of concrete. Next is the elastic shortening of concrete. So here, due to the prestress transferred to the concrete will short. Okay, it will start shortening due to the prestressing force. This also results in the corresponding shortening of steel. Okay. The loss of prestress due to elastic deformation of concrete depends upon the modular ratio and the average stress in the concrete at the level of steel. So the elastic shortening is due to the shortening of concrete, and why the concrete shortens? Because we are shortening the steel, we are applying the stressing force on the steel. From steel that force gets transferred to the concrete also, and due to the deformation or shortening of the concrete, there will be loss of stressing force due to the shortage of the concrete, and basically it depends upon the modular ratio and average stress in the concrete, okay, at the level of steel. So the formula for this is, it is in the next slide. So here the formula is M into Fc. The formula is very simple. It is, this is the formula, loss of stress in steel. It is M into Fc, where this M is the modular ratio. Here you can see M is the modular ratio, and M can be calculated as Es upon Ec, where your Es is the modulus of elasticity of steel, and Ec is the modulus of elasticity of concrete. Okay, and Fc is the stress in concrete at the level of steel. So stress in the concrete at the level of steel. Okay, so this I will also tell you once we switch to the whiteboard. What is this Fc? So just now you should know that it is the stress in concrete at the level of steel. That is Fc. So this is the formula. M into Fc. So these four losses are occurred in pre-tensioning members. In post-tensioning members, in addition to these all four losses, the fifth loss is anchorage slip. Okay. So when the cable is tensioned, the jack is released to transfer the prestress to the concrete. Okay. And the friction wedges employs the grip to the wire slips over a small distance before the wires are firmly housed between the wedges. Okay. So after it is tension, then after tension the jack releases the wire, and in between while fixing that wire to the wedges, some prestress gets lost. Okay, there will be the loss of some prestress, and this is called as the loss of prestress due to anchorage. Okay, so the formula for this it is given over here. So loss of stress due to anchorage it is ES delta divided by L. It comes from this basic formula: delta is equal to PL upon A. We know that P by A means stress. So we need to calculate the stress. So if we kept P by A as it is and we send ES over here, so it will become ES into delta is equal to PL upon A. So we send L again to the left hand side. Then the formula will become P by A. Then the formula will become this P by A is equal to ES delta upon L. So loss due to stress due to anchorage slip, loss of stress due to anchorage slip, it is ES into delta divided by L. These all terms are known to you, where delta is the slip of anchorage, L is the length of the cable, A is the area of cross section, ES is the modulus of elasticity of steel, and P is the prestressing force. So this is the formula for anchorage slip. Now this is the last loss. Okay. So loss of stress due to the friction. So the loss of stress due to the friction. Okay, so here the loss of stress due to the friction depends upon the tendon form and alignment, which generally follows a curved profile along the length of the beam. So this is also loss of here there is also loss of stress if the duct cannot be placed perfectly. So normally in the prestress you can see normally in the prestress you can see the ducts are provided, and from that duct the cable tendon is passed. Normally the parabolic cable tendons are used. Okay, and while using these parabolic tendons, if it is not ducts are not placed at the exact place, then there will be the loss of prestress. Okay, due to the alignment, if the alignment is not good, then there will be the loss of stress due to the friction. Okay. And this loss can be calculated as this is the formula. This is the formula, and it is loss of stress due to friction is mu alpha plus kx into p0. Okay. So mu, what is mu? So here we have shown that. Here now you can see mu is the coefficient of friction. Here the mu is the coefficient of friction. Alpha is the cumulative angle. So which angle is alpha now? Suppose now this angle is theta. Theta is the angle which is made by the cable profile or tendon, parabolic tendon with horizontal. Then alpha is this external angle. This is the tangent line. This is the tangent line from this point where theta angle is there. Okay. And second tangent line from the point where the second end is there. Where when these two tangents meet each other, that angle subtended by these two tangents is nothing but alpha. Generally, this alpha is equal to 2 of theta. Okay, again this is the question for MCQ. So this alpha is the angle which is subtended by this tendon which is having parabolic profile with horizontal, and this alpha is nothing but it is cumulative angle, and generally this alpha is equal to 2 times of theta. Okay, so when the value of this mu and this alpha is not given in the numerical, we take this value as 0, and our formula is reduces to loss due to the Prestress is kx into p0. Okay, so kx into Prestressing force, where k is the friction coefficient of wave effect, and its value generally given in the problem. So now these are the losses. These are the different kinds of losses which happens during the prestressing process. Okay, which happens during the prestressing process. Now these are the formulas which you need to remember. So these formulas you should remember. First is the loss of stress due to shrinkage of concrete. It is ECS into ES, where ECS is what? Shrinkage strain in concrete, and ES is the modulus of elasticity. Okay. And this ECS value again it can be calculated as, how do we calculate this value? For pre-tensioning it is 300 into 10 raised to minus 6, and for post-tensioning it is this formula 200 into 10 raised to minus 6 divided by log to the base 10 t plus 2, where t is the age of the concrete. This formula should be used. The next is the creep of concrete. So creep of concrete it is calculated by two methods. Ultimate creep strength method is the one thing, and second is the creep coefficient method. So from the ultimate creep strength method it can be calculated as EC into FC into ES, where your EC is the ultimate creep strength. Then second is FC. FC is the compressive stress in concrete at the level of steel. This FC, the formula to calculate the FC is P by A plus P E square by I. Then this ES is already known to you, Young's modulus of steel. This is the first method. Second method is the creep coefficient method. So in this creep coefficient method, here loss of stress due to pre-stress it can be calculated as by using this formula phi into m into fc, where phi is the creep coefficient. Okay. Its value is given in the below table. What m into fc, m is the modular ratio, which is m is equal to es upon ec. This formula is already known to you, and fc is equal to stress in concrete at the level of steel. So next is the loss due to the relaxation of steel. This is called as creep of steel also. This loss it is generally taken as 3%, or it is in between 1% to 3%. Okay, of initial stress in steel. It is 1% to 3% to 5% of initial stress in steel. So next is the elastic shortening of concrete. So for the elastic shortening of concrete, the formula is m into fc. A very simple formula is there. So you know what is m and you know what is fc. Then after that, Anchorage sleeve. So for the Anchorage sleeve, your formula is, it is derived from this simple formula, delta is equal to PL upon A, where P by A is stress. So P by A is we kept on this right hand side, and L and ES is sent to left hand side. So this formula is getting derived. So loss of stress due to the Anchorage sleeve is ES into delta into L. And now last one is the loss of stress due to the friction. So the formula is mu alpha plus kx into p0. Okay. And if the mu and alpha values are not given or it is 0, then this formula is reduces to kx into p0. So loss due to the length effect it is ks into p0, and loss due to the curvature effect, if the curvature is there like this, then mu alpha plus kx into p0. So this is the loss due to the friction. This is the loss due to the friction, where K is, you know, the coefficient, mu is the coefficient of friction, alpha is equal to cumulative angle, and K is equal to friction coefficient for wave effect. So I hope now you have write down all the formulas. So with this formulas now we will move to the numerical, and in the numerical also there is not much more type of variety in the numerical. Only one type of numerical is there. Find all the losses in these pre-tension members and post-tension members. Like this the problem should be there. Now we will move to our so first of all write down the problem and then we will solve it. So prestressed concrete beam is 300 mm by 300 mm in section and is provided with and is provided with 40 wires of 3 mm diameter distributed uniformly throughout the section. Throughout the section. Initially, the wires are tensioned with a pull of for given numerical. I will read it once again. A prestress concrete beam 300 mm by 300 mm. So size is known to you. Is provided with 40 wires of 10 mm, 3 mm diameter. So area of steel is also known to you. Okay. Now uniformly distributed throughout the section. So these cables are uniformly distributed. Initially the wires are tensioned with a pull of 450 kN. Determine the percentage loss of stress in the wire. Okay. So again here they have not mentioned that these wires are placed at how much it is eccentricity. Okay, so if those are placed below 100 mm from the neutral axis or 150 mm, 200 mm, nothing is mentioned. So we will consider that these wires are the concentric wires. Okay, so these tendons will be placed exactly at the neutral axis because in the problem no eccentricity is given. So here the eccentricity we will consider it as a 0 as it is not given. Okay. So now the given data, in addition to this, further given data I will write. Okay. Further given data is take ES is equal to Young's modulus of steel. It is equal to 2.08 into 10 to the power 5 Newton per mm square, that is megapascal. Then EC is equal to, all this is given data which is I am writing, this is given in the problem itself. 3.20 into 10 raised to 4 Newton per mm square. Then the the creep shortening So the grip of concrete, it is 32 into 10 to the power minus 6. Okay, 32 into 10 to the power minus 6. Next is the total shrinkage strain. So shrinkage strain is given to you. ECS value. It is 200 into 10 to the power minus 6. Okay. Sometimes they don't give you this value and they mention in the problem that it is pre-tensioned member or post-tension member. Accordingly, you have to take this. Then relaxation, relaxation loss of stress, of stress in steel, in steel is equal to 4.5% of initial stress. So all this is the given data. So let us see that how to solve this problem. First of all, prestressing force. Prestressing force is given to you. It is P is equal to what is the initial. This is your initial prestressing force. Okay, it is 450 kilonewton. This is already given to you. Then initial stress in concrete or direct stress in concrete. Our notation for this is we use always sigma 0, which is P0 by A. So it is this, you know that it is P by A, so which is equal to it is 450 into 10 raised to 3 divided by A. A is the area. Area of cross section is 300 into 300. So solve this. Let me know the answer. It works out to be 5 Newton per mm square. Please check the calculation. Then initial stress in steel wires. So this is the initial stress in or direct stress in concrete. So stress in steel wires. So how to calculate that stress? So for this we use the notation sigma T. So here you can also use sigma C, direct compressive strength, or sigma 0, whatever you like. Notation doesn't matter. The stress in steel wires is sigma T. And it is again calculated as load divided by area. Okay. Now for this area, it is 450 into 10 raised to 3 divided by what is the area? It is pi by 4 into 3 square into 40. Such 40 wires are there. Area of steel we need to consider. We are talking about stress in steel. So it is 1591.55 Newton per mm square. This is your direct stress in steel wires. Okay, initial direct stress. So it is simple. Just we have used the formula P by A. Nothing is much more complex. For concrete we have used the area of section. For steel we have used the area of steel. That's it. Okay. So now next is we will calculate the modular ratio. So the modular ratio M is equal to, it is ES upon EC. which is equal to ES is given as 2.08 into 10 raised to 5 divided by EC is given as 3.2 into 10 raised to 4. So if you solve this, you will get the value of M as 6.5. 6.5. So now we will calculate the various types of losses. So here I will write the various types of losses of stress are as follows. First is the shrinkage loss. Shrinkage loss or loss of stress due to shrinkage. Okay, you can call it as in either way. Loss of stress due to shrinkage, loss of prestress due to shrinkage, or shrinkage loss. So it is equal to shrinkage strain, that is we know the formula, shrinkage strain, that is ECS into ES. This is our formula. Okay, which is equal to, what is the value of ECS given in the problem? Shrinkage strain, it is given as, this is the value of shrinkage strain, 200 into 10 raised to minus 6. So it is 200 into 10 raised to minus 6 into what is the ES? The value of ES is also given. It is 2.08 into 10 raised to 5. It is 2.08 into 10 raised to 5. So if you solve, you will get the answer. It is 41.60 Newton per mm square. It is 41.60 Newton per mm square. This is the first loss, shrinkage. Okay. Then the second, elastic shortening. Elastic shortening. Just see the formula and put the values. Nothing is much more complicated over here in this chapter. Just see the formula and put the values. That's it. So elastic shortening. The formula for elastic shortening is, what is the formula? It is m into Fc. Okay. Now we need to calculate the value of this Fc. Therefore, now what is the Fc? Fc is the stress in concrete at the level of steel. It is calculated as P by A plus P E square by R, which is equal to P by A. So what is the value of P? 450 into 10 raised to 3 divided by A. Area of section is 300 into 300 plus 0. Why it is 0? As tendon is concentric, eccentricity is 0. Okay. So if the eccentricity is 0, then the term will become 0. Now how does this Fc come? See, suppose this is the cross section. This is the cross section, and now you have provided the reinforcement. Suppose now you have provided the reinforcement somewhere here at this point. Okay. Here are your cables, and the neutral axis. If I draw the neutral axis, then this neutral axis will be here at this point. So this is the neutral axis. Now Fc means what? Stress in concrete at the level of steel. Now if you draw the direct stress diagram, due to the prestress we want to calculate the stress. This is the diagram. This is your P by A diagram. if I want to calculate the stress then at this level, okay, at this level, so what is the stress at this level? Now I want the stress at this level with the concrete. This is the concrete, direct stress in concrete. So this is called as FC. In this case, this is FC. Okay. But normally, what is happening here? Here the eccentricity is not zero. Okay. So here you will get some value, but here the eccentricity is not zero. It is at some eccentricity E. Then you need to consider the another diagram also into the calculation, and that another diagram is the loss of stress due to eccentricity. Okay. Stress due to eccentricity, that also you need to consider over here. Stress due to eccentricity. And if I draw that diagram also, stress due to eccentricity, then it will be like this. Tension at top. Okay, normally tension at top and compression is at bottom. So this type of diagram is there. So here this is your PE by Z. Stress due to eccentricity, PE by Z. And you need to add this value also. So at this level now, what is the stress? At this level we want to calculate that stress here. So these are the two levels. So when you add these two, suppose now this is X or this is P by A. This is P by A and plus, okay, plus you need to find out this value. How do you are going to find out this value? By using this triangle. Okay, by using this triangle for this much of depth, P by A, PE by Z is the value. For this much of depth, how much is this value? Okay, and this value is works out to be, it is PE square by I. P is Z is equal to I by 1. Okay, and this distance is nothing but this is your eccentricity. This is your eccentricity. Okay, so for this much of distance, okay, it is PE by Z. So this is the extreme distance. This is the extreme distance. So this is your Y. For a distance of Y, it is PE by Z. For a distance of E, it is how much. In that way, this can be calculated and it works out to be PE by Z. And when you add these two, okay, when you add these two, then you will get the formula P by A plus PE square by R. Okay, and this is the formula to calculate this FC. Here the stress in concrete. This is called as FC. Okay, stress in concrete at level of steel. स्टीलच्या त्या लेवल मधला कॉन्क्रीट मध्ये काय स्ट्रेस असणार बट when here E is having some value and now in this formula in our case what is happened here if I write in this numerical E is equal to 0, E's value is not given, so this term will become 0. E square by I, whatever is this term, this becomes 0 because E is 0. So it will remain P by A. So this diagram will not be there. As E is 0, this diagram should not be there, will not be there. Okay. So that is why if you calculate this FC now, Again, if you move to the problem and you calculate the FC, then this FC is works out to be, again, it is 5 Newton per mm square. Okay. It is 5 Newton per mm square. This is the value of FC. Now calculate the elastic shortening. Just put the value. Once you know the value of FC, here in this formula, just you have to put the value. This diagram is not necessary to draw in the examination. For your understanding purpose, how this formula has come, that is why I have explained this. So now it is m into FC. So here I will write elastic shortening is equal to m, the value of m is 6.5 into 5. Okay. 6.5 into 5. So it works out to be 32.5 Newton per mm. Okay. Then next is the loss due to creep of concrete. The third, loss due to creep of concrete. Loss due to creep of concrete. Now here we will see what is given in the problem. Okay. So here you can use the formula creep m into 5 into fc is also you can use, or another formula here. What is the second formula for this creep calculation? It is creep strain into fc into es. That also you can use. So here you can see phi is not given to us, that is creep strain is not given to us, but creep shortening is given. So ec is given to us. It is 32 into 10 raised to 6. So it is ec into fc into es. So the formula is ec into m into fc. So m into fc is already known to elastic shortening multiplied by ec. So you will get this value, loss due to the creep of concrete. Okay, m into ec. Sorry, here it is fc into ec. Okay, es. Here the value of es, it is given as 2.08 into 10 raised to minus 5. Okay. So now just use this formula, just remember the formulas. So here EC is equal to, how much it is given? It is 32 into 10 raised to minus 6. 32 into 10 raised to minus 6 into FC is 5 into ES is 2.08 into 10 raised to 5. So if you solve, you will get this value as 33.28 Newton per mm square. Newton per mm square. Now the fourth law, relaxation of steel. Or it is also called as creep of steel, which is equal to 4.5% of initial stress. So I will write here, it is given in problem 4.5% of initial stress in steel. प्रॉब्लेम मध्ये दिलेलं आहे 4.5% घ्या म्हणून. हिअर it is given 4.5%. Okay. So which is equal to 4.5% means 4.5 divided by 100 into what was the initial stress. So this is the stress in steel wires, that is the initial stress. It is 1591.55. So it is 1591.55. So if you solve, you will get the answer. It is 71.62 Newton per Newton per mm square. Okay. Now if you see the problem carefully, here if you see the given data, there is no anchorage slip is given to you. Okay, the value of delta is also not given to you, and the value of mu alpha, that is for friction. So you cannot find the loss due to the anchorage slip, and you cannot find the loss due to friction. Okay, so here only this much of data is given to you, so you can find out these losses. So these are the losses which are occurred in pre-tensioned members. So now after this, we will calculate the total loss. So the total loss is equal to, what is the total loss? It is 41.6. Add all these plus 32.5 plus creep is 33.28 plus 71.62, which works out to be 179 Newton per mm square. This is the loss of Prestress. This is the total loss of Prestress. Okay. So now we will calculate the percentage loss. So the percentage loss of Prestress is equal to, percentage loss of Prestress is equal to, लॉस किती झालेला आहे 179 डिवाइडेड बाय पर्सेंटेज लॉस. इनिशियली किती होता स्टील मध्ये इनिशियल स्ट्रेस किती काढला होता आपण 1591.55. सो इट इज 1591.55 ओके into 100, which is equal to how much? 11.24%. So this is the 11.24%. And if they ask you, इथपर्यंतच प्रॉब्लेम आहे, इथपर्यंतच विचारले, and if further, if in the problem it is they ask you, suppose now calculate the final stress in steel. If in this way they ask you, then how to calculate the final stress in steel? So the final stress in steel, what is the final stress in steel now? Final stress in steel is whatever may be the initial stress, 1591.55 minus लॉस किती झालेला आहे 179. सो इनिशियल मधनं लॉस मायनस केला की तुम्हाला काय मिळेल फायनल स्ट्रेस. सो इट इज 1412.55 Newton per mm square. Is it okay now? Just see the steps once again. If you have taken the screenshot or if you have written down everything, just see the steps. I will give you 1 minute, just see the steps. Let me know if in any step you are having any problem. So just you have to add the formula and just put the value. So now further, if they have asked you what is the final stress in concrete, then how you will calculate the final stress in concrete? How you will calculate the final stress in concrete? So here I can write final stress. This is the final stress in steel. Okay. So if they ask you further final stress in concrete, then final stress in concrete must be equal to initial stress. सेम फॉर्म्युला आहे वर जे स्टील साठी वापरलंय ना तेच सेम करायचंय फक्त मी वर्ड्स मध्ये लिहायला लागलो म्हणजे वर मी लिहिलेलं नाहीये फॉर हियर फॉर स्टील आय हॅव नॉट रिटन इन वर्ड्स द फॉर्म्युला that is why I have written over here. It is actually not a formula, it is a logic how to calculate that answer. Okay, so it is initial stress minus loss. Okay, it is initial stress minus loss. So initial stress is 5. We have calculated P by A in concrete. If you remember, हा तुमचा स्टील मधला इनिशियल स्ट्रेस आहे आणि हा कॉन्क्रीट मधला आहे. सो कॉन्क्रीट मध्ये 5 आहे. सो इट इज 5 मायनस लॉस किती झालाय 11.24% प्रिस्ट्रेस. सो हियर 11.24 divided by 100. It is percentage into stress in concrete. Okay, initial stress in concrete. So if you solve this, you will get the final stress in concrete. Stress in concrete, and it works out to be 4.438 Newton per mm square. 4.438 Newton per mm square. Or you can calculate by another method also. If it is not understood to you, then you can calculate it by another method also. Here I can say final, whatever final force in concrete must be equal to final force in steel for equilibrium. Okay, so force can be calculated as stress into area. So for concrete it is sigma c into AC or sigma 0 initial stress. Okay, that we will take into the account. For concrete, now we are talking about the final stress. So let it be sigma. I will not give you any notation. Sigma, which is equal to final force in steel. Okay, so final stress in steel into area of steel. Okay. So for concrete I will write C. So sigma C as it is into AC. I will AC is what? Area of concrete. So here this area is known to us. It is 300 into 300, which is equal to sigma T. That is the final stress in steel. So the final stress in steel we have calculated already. What is the final stress in steel? This is the final stress in steel. Okay, this is the final stress in steel. So it is 1412.5 into area of steel. It is pi by 4 into 3 square into 40. So if you reshuffle the terms, therefore sigma c is equal to, this is or I am telling for last. So it is 1412.5 into pi by 4 into 3 square into 40 whole divided by 300 into 300. So therefore, if you solve this also, you will get the same answer, 4.438 Newton per mm square. So by either way, you can do it by this way or either this way. This is easy. Okay. In short, you will get the answer, but in book, this is given. Okay. In textbook, if you refer textbook, this is given in the textbook. This is also not wrong, but little bit lengthy. But if you follow this, this is the shortcut which I am telling to you. Just use the logic. If you use the formula, it will become too much big like this. So just use the logic. That is the final stress मला पाहिजे. तर जो काही इनिशियल असणार आहे, सुरुवातीला 100 अप्लाय केलाय, त्यातला जर 20 लॉस झाला असेल तर फायनल काय राहिला, 100 मायनस 20. सेम लॉजिक वी हॅव अप्लाइड हियर. Final stress in the concrete is nothing but initial stress in the concrete minus loss. So initial stress in concrete is was 5. Okay, minus loss किती झालेला आहे, how much, 11.24%. Okay, so 11.24 into 100 of initial stress. So initial is 5. So this quantity, this loss, if you subtract from 5, you will get the answer directly. So in this way now, you can calculate the losses. Okay, you can calculate the losses in the members. So it is very easy. So now next problem, we will take some a little bit complicated problem. So that it requires some tedious calculations. So take the next one. The pre-tensioning beam. I am supposing that you have understood this problem because nobody has asked me any difficulty. I have given you the time of 1 minute to go through all the steps. Still you have not had many difficulties, so I think it is understood by you. Okay, it is my assumption. Now I don't know how much it is correct. Okay. So the problem will not get completed in this lecture. Okay, now 2:45 is the time, and also at 3 o'clock I am having a meeting. So now today we will stop over here.